Kubernetes is a powerful platform for managing containerized application. Let's explore its architecture through a simplified explanation of key components and workflow. So you can imagine a vast ocean teeming with a containerized application, each like a specified cargo ship. Kubernetes acts as your captain and crew, ensuring these ships work together seamlessly. Here's how it all works. So, understanding Kubernetes components. In Kubernetes, right, there are two main things of note, or you can say two main types of nodes. One is a master node, and two is the worker node. So, now let's understand what are the components that are in the master node, or you can also say the captain's quarters. So, this is a control center, basically the helm of your fleet. So with the very first component that we are going to talk about is the API server. In Kubernetes terms, the API server acts as the central control point, similar to the captain's cabin on the lead ship in the fleet. It receives requests from the users and other components, acting as a single point of entry for all the Kubernetes API calls. Just like the captain receives reports and issues commands to manage the entire fleet, the API server coordinates communication between various Kubernetes components, validates the request, and ensures the desired state of the cluster is maintained. It is like a brain and it's the communication hub of your Kubernetes operation. The next one is the scheduler, or you can also say it is a navigator on the ship. It's like a seasoned navigator. It assigns the task. Here, the task coordinates to containers and it assigns to a specific ships or the worker nodes based on the resources availability or the capability, right? It considers the factors like available space, power to ensure smooth operation. Imagine the scheduler has a highly skilled navigator who analyzes wind pattern, water depth, and cargo weight before assigning a specific route to the destination to each ship. Here, the scheduler is the navigator, and whatever we told analyzes the wind pattern, water depth, and all. Basically, it will analyzes the resource availability on such as the CPU, memory, and all those things. And the next component is the controller manager, or you can say the chief mate. The chief mate keeps a watchful eye on the entire cluster and it ensures everything runs as planned. So it oversees the health of your application and takes corrective actions if needed. So in Kubernetes, right, the controller manager acts as a group of dedicated officers constantly monitoring the cluster's health. So let's say if a container goes down or malfunctions, the controller manager initiates the corrective actions to get things back on track. Next, very important thing is the etcd controller or etcd. So in terms of the example that we are talking about, we can call this as a logbook. So basically this is a special storage room that holds all the important fleet information such as the cluster data. So it makes for easy for us to access the cluster data. So it's like a ship's logbook, a central repository for crucial details. So it will log who logged in or where the pod was created, on which node it is running, which are the nodes we have, all these details. The etcd in Kubernetes is a distributed key value store that acts as a single source of truth for all the cluster data. So it ensures consistency and allows all components to access the latest information about the fleet or the cluster. Next is the worker nodes. Let's discuss about the components that we have in the worker nodes. We call the worker nodes as the cargo ships. So these are the worker horses that the ships carry your containerized application. So the very first component that we are talking about is a kubelet, or we can also say that as a first mate. So the first mate on each ship or the node is responsible for managing the containers or the crew and reporting back to the captain. Here it is the API server. So it will ensure that the containers are happy, healthy, just like the first mate keeps the crew well maintained. The kubelet on each worker node acts as the first mate, constantly monitoring the health of containers running on that node and reporting any issues to the API server. API server is referred as a captain of the ship. And we have the engine room. Engine room is corresponding to the container runtime. It can be Docker or it can be Racket or anything, right? So this is the engine that allows the containers to run. Similar to the engine room that keeps the ship chugging along, softwares like Docker acts as a container runtime in this analogy. The container runtime on the worker node is like the engine room. So it provides the necessary environment for containers to run and execute your application. Next is a kube proxy, or we can also say that as sales. So this manages how ships communicate with each other, basically the network connectivity and the routes. Just like the sails allow ships to navigate and interact, kube proxy ensures smooth communication within your fleet. Imagine a kube proxy as a network of skilled sailors who adjust the sails and rudders to ensure all ships can communicate and collaborate effectively. Now let's understand the workflow after applying a deployment. Let's explore how the workflow when applying a Kubernetes deployment. Let's say a user defines a Kubernetes deployment manifest. So he will specify all the requirement details and into a manifest file, which consider the details like this. And then he will go ahead and run kube apply command, and that sends the deployment manifest to the API server. So then the task of the scheduler comes in. Scheduler assigns the pods or the containers to the suitable worker nodes. Next, kubelet on each node starts the pod based on the deployment specification. So if the specification is asking to run the pod on all the worker nodes, it will go ahead and do so. If you know what is called, please let me know in the comments. And the answer is the daemon set. The fifth layer is the container runtime. Basically, the container runtime pulls the container image and runs the pod. And if in case you have deployed, or if your deployment includes a service definition, the API server interacts with kubeproxy to create a service. And kubeproxy manages the network connectivity and service routing within the cluster by updating IP tables and handling packet forwarding. So this is how a workflow of the Kubernetes deployment looks like. Next, let's see how to interact with Kubernetes. So we have a very famous tool called command line tool, which is kubectl or Kubernetes controller. So this tool is helping you out to manage Kubernetes cluster. For example, let's say you want to view the running pods. Then you will simply go ahead and type kubecontroller or kubectl get pods. Next, let's say you want to list all the deployments. Then you'll simply go and type kubectl get deployments. Next, let's say you want to explore a detailed pod information. Then you just type in kubectl describe pod and specify the pod name. So Kubernetes simplifies container management with its architecture and workflow. Understanding these components enables efficient deployment and orchestration of containerized application. So start exploring Kubernetes confidently and leverage its capabilities to manage your applications effectively. Happy deploying with Kubernetes. Until then, take care. Bye bye.